Forget the dusty skeletons gathering web cobs in silent museums. Forget the clumsy gray claymation monsters from old black and white films. To truly understand the creatures that once owned the very ground you stand on, you must first scrub your mind clean of fiction. Picture this instead, a world where the air is so thick with oxygen it tastes sweet, where dragonflies the size of hawks zip through ferns as tall as houses, and where the hierarchy of life is brutally simple: eat or be violently obliterated. We represent the thin sliver of time after the apocalypse. They represent the definition of planetary dominance. For over 160 million years, dinosaurs didn't just survive. They engineered ecosystems, refined killing to a science, and pushed the absolute boundaries of what biology allowed. They were experiments in extreme living. Imagine walking through a jungle and hearing a sound not of a bird, but of a rumble so low it vibrates in your teeth before you even register it. Imagine a predator so massive, its shadow alone paralyzes its prey. This isn't fantasy. This is prehistory, raw and unedited. Today, we are not just listing names. Names are boring. We are diving into the record books of the Mesozoic. We are counting down 5 specific titans that took one biological trait and cranked it up to an absurd, terrifying, or ridiculous level. These are the holders of the most titles, the absolute outliers, the freaks of evolution. Prepare yourself. We are about to meet the rulers of the extremes, starting with a creature that redefined the very geometry of living structures. If you think you know dinosaurs, think again. The reality is far stranger and much more dangerous.
Imagine holding a fishing rod that is 30 feet long. Now, try to hold it steady from the very end. The physics are impossible. The leverage would tear your wrist apart. Now, imagine that fishing rod is made of flesh, blood, and solid bone, and it is attached to your own shoulders. This wasn't a physics nightmare. It was daily life for the Mamenchisaurus. Found in what is now China, this gargantuan sauropod didn't just have a long neck. It possessed a structural anomaly that seems to defy the laws of gravity. While the famous Brachiosaurus had a neck optimized for reaching heights like a biological crane, Mamenchisaurus specialized in pure horizontal geometry. Its neck was an astounding 30 to 40 feet in length, making up nearly half of its entire body. We are talking about a structure longer than a standard city bus, all jutting out from a massive 4-legged torso. How did evolution allow this? How did it not simply snap? The secret lay in architecture. The vertebrae of its neck weren't solid rocks. They were marvels of bioengineering, hollowed out, air-filled, and reinforced with internal struts, like the struts of an airplane wing. This made the structure incredibly light for its size. But lightness alone isn't enough. You need control. Mamenchisaurus had neck ribs, long rod-like bones that overlapped, creating a rigid yet flexible sleeve of support along the spine. Picture a bundle of reinforced cables. This gave it the strength to hold that impossible lever, but at a cost. It couldn't curve its neck like a swan. It moved more like a slow, majestic, biological construction crane. But why? Why develop a feature so extreme? The leading theory is the ultimate biological driver: efficiency. The late Jurassic environment was a competitive buffet. While other sauropods fought for the high branches or the ground foliage, Mamenchisaurus discovered a cheat code. It could stand in one single spot, never moving its heavy body, and its neck could sweep a massive 180-degree arc of vegetation. It was the ultimate lazy diner, harvesting tons of food with minimal caloric output. It paid the price in vulnerability, a 30-foot target for any lurking predator, but it succeeded by mastering the art of the long-reach harvest. It was a giraffe, but one designed by a committee obsessively focused on structural maximization.
You are a small, fuzzy mammal, a distant relative of ours, scurrying through the leaf litter of the early Cretaceous. The air is quiet, perhaps too quiet. You stop, sensing something. Not a sound, but a ripple, a movement in the shadows that is too fast to be a falling branch. Suddenly, you're not on the ground. You're held fast by sharp, tiny claws, and above you, a face like a nightmare, A beak filled with serrated daggers is descending. This isn't a wolf or a hawk. This is a killing machine the size of a pigeon. Meet the Microraptor, the undisputed holder of the title for smallest size in this countdown, and a creature that shatters the stereotype of dinosaurs as slow, lumbering giants. While its cousins, like the Utah raptor, were pushing the limits of ground-based predation, Microraptor went in the opposite direction. Evolution didn't just shrink it, it redefined its entire locomotive toolkit. This tiny, feathery nightmare, found in the fossil beds of Liaoning, China, didn't just have wings, it had four. Yes, four. Long, asymmetrical flight feathers covered not only its arms, but its hind legs as well, creating a secondary pair of wings. This discovery was a bombshell in paleontology. How did it use them? It wasn't a powerful, flapping flyer like a modern eagle. Instead, most experts believe it was a master of a different craft, biplane gliding. Picture a flying squirrel, but covered in feathers and optimized for aggressive maneuverability. It would climb high into the ginkgo trees and launch itself, using its four wings and a long feathered tail as a rudder to control its descent. This setup made it an incredibly agile aerial hunter, capable of weaving through the dense forest canopy with precision. It was the stealth fighter of the Cretaceous understory. It preyed on insects, lizards, and small mammals, striking from above with terrifying speed. We know this because scientists have found fossils with the contents of their last meal still preserved in their stomachs. A lizard, in one case, swallowed whole. Even its color was a weapon. Analysis of pigment cells in its well-preserved fossils revealed that Microraptor was a glossy, iridescent black, much like a modern raven. This wasn't just for show, it was camouflage, allowing it to blend into the dappled shadows and launch its silent, lethal glides unseen. It proves that dominance in the Mesozoic wasn't just about massive muscle and bone-crushing power. Sometimes, the most effective evolutionary path was to be small, fast, dark, and utterly silent.
There is a moment in the life of any prey animal where all hope dies. It is the moment it realizes it cannot outrun the shadow. Now, let us refine that shadow. Imagine the shadow is attached to a 40-foot-long predator, weighing 8 tons and walking on 2 massive legs. Now, let's focus on the head. A skull the size of a sofa, built like a cage, carrying 60 serrated, banana-sized teeth. This is not just a monster. This is a Tyrannosaurus rex. But we are not celebrating its fame. We are celebrating its engineering. Specifically, the terrifying statistic that gives it the title of most powerful bite. Paleontologists and engineers have spent decades modeling the biomechanics of that massive skull. They analyzed the bone density, the muscle attachments, and the structural dynamics. And the numbers they produced are staggering. A single bite from an adult T-Rex could deliver a force of roughly 35,000 to 57,000 newtons. To put that in perspective, that is like having a medium-sized pickup truck sit directly on its lower jaw, concentrated on just a few teeth. Why did it need such overkill? Look at its neighbors. Triceratops and Ankylosaurus weren't just meat, they were walking armored banks. A conventional slash and bleed bite, used by many other theropods, would just snap teeth against their bony hides. The T-Rex didn't slash, it pulverized. Its teeth weren't sharp like steak knives, they were thick, conical, and reinforced, optimized not to cut, but to crush bone. And its skull was engineered to absorb that massive feedback force. The joints in its skull were slightly mobile, acting like shock absorbers, preventing the force of its own bite from shattering its brain case. A T-Rex didn't just kill its prey, it annihilated the skeleton of its prey. Fossilized T-Rex dung has been found packed with pulverized bone, proving that they were osteophages, bone eaters. They would bite into the pelvis of a Triceratops, not for the meat, but for the calorie-rich marrow inside the bones. That massive bite was a specialized tool, a logical evolution designed to crack the toughest evolutionary defense mechanisms of its time. It wasn't just a threat, it was a physical constant, a force of nature that defined the rules of survival in the late Cretaceous of North America. When that jaw closed, the debate was over.
Imagine you are an evolutionary biologist tasked with designing a creature for a prank. You decide to take the body of a T-Rex, but you make it vegetarian. You shrink the arms, but you replace the hands with bizarre forward-pointing shovels. You add a long neck, a tiny head with a beak, and a potbelly. You are looking at the Dinosaurs, the holder of our most bizarre appearance title, and perhaps the most confounding puzzle in paleontology. When its fossils were first discovered in the Gobi Desert of Mongolia in 1948, the findings were so strange that scientists initially identified the massive 3-foot-long claws as belonging to a giant turtle that used them to harvest seaweed. It took decades to assemble the full, ridiculous truth. This was not a turtle, it was a theropod, the same lineage that gave us the T-Rex and the Velociraptor. But the Dinosaurs was the ultimate nonconformist. It had taken the theropod blueprint and twisted every single rule. The most defining feature, of course, were those claws. Each was as long as a human arm, scythe-like, and attached to massive, robust arms. If a T-Rex saw these claws, it would probably think, finally, someone with decent reach. But the Dinosaurs didn't use them to disembowel prey. Look closely at its anatomy. It had a massive, heavy, round torso, indicating a vast digestive system for fermenting tough, low-quality vegetation. Its teeth were leaf-shaped, meant for clipping plants. Its head was ridiculously small for its body, sitting at the end of a long neck. And those claws? Their primary function was likely not defense, but harvesting. Picture the creature using those massive scythes to hook high tree branches and pull them down to its small, beaked mouth, like an evolutionary gardener using 2 pairs of giant hedgerows. Or perhaps it used them to rip open giant termite mounds, though its slow movement would make that a risky strategy. But defense was likely a close second function. Even if it was peaceful, those claws, when wielded by a multi-ton creature, were still lethal weapons. A swing from those scythes could deter the most determined Tarbosaurus. The Dinosaurs is a reminder that evolution doesn't always move in a straight line towards sleek or deadly. Sometimes a successful niche is found by taking the entire design blueprint, throwing it away, and starting again with the most absurd combination of features possible, simply because it works. It was the original punk rock star of the Mesozoic. Weird, loud, and utterly unforgettable.
Imagine an animal so large that its heartbeat sounds like a muffled drum deep within a mountain. To stand next to a Mamenchisaurus is not to stand next to an animal, it is to stand next to a biological skyscraper. But the true horror or wonder of this creature lies in its daily survival. To maintain a neck that reaches 40 feet into the sky, the heart of this beast had to be a muscular engine of incredible power. Imagine the blood pressure required to pump life all the way up that impossible straw to a brain the size of a loaf of bread. If the Mamenchisaurus lowered its head too quickly to drink, the sheer rush of gravity-driven blood could have caused a lethal brain hemorrhage. Evolution had to install a series of complex valves in the jugular veins, a biological braking system to keep the animal from exploding from the inside out. And then there is the sheer volume of consumption. This wasn't a creature that ate, it was a creature that harvested. A single Mamenchisaurus needed to strip hundreds of kilograms of ferns and conifers every single day just to keep its massive furnace burning. They lived in a state of perpetual motion, their long necks swaying like heavy cables in the wind, clearing entire forests of their greenery. When a herd of these giants moved through a valley, they didn't just leave footprints, they reshaped the geography. Trees were snapped like toothpicks, the ground was compacted into stone-hard trails, and the sound of their collective breathing was like a rhythmic gale. But there is a darker side to being the most in length. A long neck is a long target. For a young Mamenchisaurus, life was a desperate race to grow. A predator didn't need to take down the whole beast, it only needed to leap and tear at that exposed fleshy pipe. The scars found on fossilized neck vertebrae tell stories of narrow escapes, deep gouges where the teeth of a synraptor once clamped down, only to be shaken off by a desperate whip-like lash of that gargantuan neck. To be the longest was to be the most exposed, a life lived on the edge of structural and predatory collapse. The Cretaceous night is never truly dark, and it is never truly safe. High above the forest floor, where the wind whistles through the prehistoric pines, a shadow detaches itself from a branch. It doesn't fall, it slides. This is the Microraptor in its element, a 4-winged phantom that turned the sky into a killing floor. While the giants roared below, this tiny terror operated in a realm of high-speed geometry. Scientists using laser-stimulated fluorescence have peered into the very cells of Microraptor fossils, revealing a secret hidden for 120 million years. Their feathers weren't just for flight, they were a signal. The iridescence we see today in starlings or crows was present in Microraptor, meaning they shimmered with a metallic, oil-slick sheen. Imagine a hunter that looks like a living jewel, yet possesses the cold, calculated instinct of a hawk. But why 4 wings? Modern birds found that 2 were more efficient for long-distance travel, but Microraptor wasn't interested in migration. It was a specialist in the cluttered environment. In a dense jungle, a traditional bird is at a disadvantage. Branches get in the way. But with 4 wings, Microraptor to generate incredible lift and execute hairpin turns that would stall any other flyer. It was the ultimate ambush predator of the canopy. It would wait, perfectly still, its dark feathers absorbing the moonlight, until a small mammal or a feathered relative strayed too close. Then a silent launch. No flapping, just a controlled, lethal glide. The last thing its prey would see was a flash of iridescent black and the glint of tiny, needle-like teeth. The tragedy of the Microraptor is that it represents an evolutionary dead end. The 4-wing design eventually lost out to the 2-wing model we see in the sky today. But for a few million years, these tiny, shimmering dragons were the undisputed masters of the air, proving that in the world of dinosaurs, being the smallest was simply a different way of being the most dangerous.
Let's go back to that bite. 57,000 newtons of force. It's a number so large it loses meaning until you see what it does to a living body. When a Tyrannosaurus rex clamped its jaws onto the spine of an Edmontorosaurus, it wasn't a clean kill, it was a catastrophic structural failure. The sound would have been like a bag of wet glass being crushed by a sledgehammer. The T-Rex didn't have the luxury of hands to hold its prey. Its face was its only tool, so evolution turned that face into a biological hydraulic press. But here is the secret that makes the T-Rex the true king of the most: its eyes. While most predators have eyes on the sides of their heads, the T-Rex had forward-facing, binocular vision. It could perceive depth better than a modern hawk. Imagine being hunted by something that can see you in 3D from 6 miles away, can smell your fear through miles of dense forest, and possesses a bite that can snap a telephone pole like a twig. There was no hiding. The T-Rex was a pursuit predator that used its massive legs to sustain a terrifying, rhythmic pace. It didn't need to outrun you in a sprint, it just needed to outlast you. And when it finally caught up, the end was instantaneous. The strongest bite wasn't just for feeding, it was a territorial statement. We find T-Rex skulls with massive bite marks from other T-Rexes, scars that healed, showing that these titans fought each other for dominance, locking jaws in a brutal test of who could exert the most pressure before a bone gave way. To live as a T-Rex was to live in a world of constant, high-stakes violence, where your only defense was being the one who could bite the hardest. It was a crown made of teeth and reinforced calcium, held by a king who reigned through the sheer physics of destruction.
In the sweltering heat of the Mongolian desert, a creature moves with a heavy, swaying gait that seems to mock the very idea of a predatory dinosaur. This is the Therizinosaurus, the giant that looks like it was assembled from the leftover parts of a dozen different species. But look at those claws again. 3 feet of curved, keratin-sheathed bone. If you saw those claws emerging from the brush, your instinct would tell you to run, expecting a carnivore of unimaginable ferocity. But then, the head appears, tiny, beaked, and almost comical. This most bizarre dinosaur is a testament to the weirdness of convergent evolution. It evolved to fill the same role that giant ground sloths would fill millions of years later. It was a high-reach browser, a creature that used its terrifying weaponry for the most peaceful of purposes, eating leaves. But don't mistake its diet for weakness. The Therizinosaurus was the ultimate don't-tread-on-me animal. While a T-Rex relied on its bite, the Therizinosaurus relied on its reach. Those claws were like 3-foot-long rapiers,
If a predator like Tarbosaurus, the Asian cousin of the T-Rex, tried its luck, the Therizinosaurus wouldn't run. It would stand its ground, rising up on its powerful hind legs to its full height of 16 feet and lash out with those scythes. One well-placed swipe could unzip the belly of a predator or gouge out an eye from a distance where the carnivore couldn't even reach with its jaws. It was a wall of blades. This dinosaur proves that evolution loves a wild card. It took the body of a killer and turned it into a peaceful, pot-bellied giant, but it left the weapons behind just in case. It lived in a world of extremes by being the most confusing thing on the landscape, a gentle giant that carried the most lethal hands in the history of the world.
So why do we obsess over these mosts? Why does the longest neck or the strongest bite still haunt our dreams millions of years after the last of them drew breath? Because these creatures represent the absolute limits of what life on Earth can achieve. They are the benchmark. When we look at the Mamenchisaurus, we see the limit of gravity. When we look at the T-Rex, we see the limit of power. The Microraptor shows us the limit of grace, and the Therizinosaurus shows us the limit of biological imagination. They remind us that the world we live in now, with our familiar cows, dogs, and birds, is just one version of reality. There was another version, one that was louder, bigger, and infinitely more dangerous. These 5 record holders weren't just monsters. They were successful solutions to the problem of survival. They dominated the planet for a span of time that makes human history look like a heartbeat. And while an asteroid eventually cleared the stage, their legacy isn't just in the stones we find in the dirt. It's in the birds outside your window, in the fear that tingle in your spine when you walk into a dark forest, and in the realization that the most is a title that is always waiting to be claimed by the next great experiment of evolution. The Mesozoic wasn't just a chapter in a book. It was a riot of life pushing against the walls of the possible. And as we've seen today, sometimes life doesn't just push, it breaks through with 50,000 newtons of force.